Good morning, students. I hope you all are doing very well. I have already provided you the complete syllabus of maths, and here we shall begin our maths with the chapter number 1, which is integers. First, let's recall what you have studied in class 6 about integers or the things related with integers. So from there you have an idea already about what are numbers. So you have studied a lot types of numbers. For example, you have studied natural number first of all. What are natural numbers called other than this name? These are called counting numbers. And you know about it. And then you have studied about whole numbers. And in the previous class, you have already studied about some negative numbers, and therefore you were being introduced with integers. So a sense of this concept has been already given to you. Now we shall explore this topic in this class. You already know. Let's take a quick review of what are these numbers. So natural numbers, you already know that these are counting numbers. So they are listed as 1, 2, 3 and so on, and it goes up to infinity. And it is kept in this particular manner. It is kept in this curly bracket, and these are separated with the help of these commas. As they go up to infinity, there is no end for these numbers, so we just apply this dash. Next we have whole numbers. Whole numbers are the natural numbers exactly, but with the another number which is 0. So what are whole numbers? So basically whole numbers are 0 and all the natural numbers. We list them in. Next you have studied what are negative numbers. So if we have these numbers, the natural numbers 1, 2, 3 and so on, so we can have the negative numbers as well. Just we apply the minus symbol and we write the numbers like -1, -2, -6, -8 and so on. They may be infinite numbers which are negative numbers, and therefore you had an idea about what are integers. So there you have studied what are integers. You studied that integers. Let's study this with the help of number line. So if this is a number line, there is a 0, okay, and here we mark or we represent this 1, 2, 3, 4, 5 and so on up to infinity. It goes up to infinity. What are these? These are natural numbers. Then what we have studied, that along with 0, all of these numbers up to infinity becomes the whole numbers. So what are these numbers? These are whole numbers. Next we had -1, -2, -3, -4 and so on, and it also goes and proceeds towards infinity. So these are called negative numbers. Right? So you have studied in the previous class that what are integers. So integers are this complete number, that if you are including these positive numbers, these negative numbers and with 0, then these are called integers. So basically integers are the positive numbers which we denote by I plus, the negative numbers which we denote by I negative and 0. Basically it is the consolidation of all these numbers. When all these numbers are combined, or we have a sense of consolidation of all these numbers, positive, negative and 0, then we say it is forming a set, which is set of integers. For now, you need to understand that simply integers are the negative numbers, the positive numbers, the negative numbers and 0. So I hope that you have an idea about what integers basically are, and you have recalled your all concepts which you have studied in the previous class. And there you have also studied how integers are added, subtracted. This is very easy task. So I will suggest you to recall your concepts about addition and subtraction, how to add the integers and subtract the integers, so that we can further proceed. For now, I'm giving you a rough and quick idea about how the things are subtracted and added in case of integers. For example, if we take 5 and if we take -4 and someone asks us to add these two numbers, so what we do is we write 5, we apply plus because we are asked to add these numbers, right? And then we write down the next number, which is -4. Then we simplify this thing, and we have studied in the previous class that what is this? Plus minus becomes minus ultimately, so this gives us -4, and that's how we solve it. That subtracting 4 from 5 gives us 1. Quite easy, isn't it? Now here in this class, in this standard, we shall be more focused over multiplication and division of integers. So we are going to start our multiplication of integers, that how integers are multiplied and what is the rule we actually follow when we multiply two integers. So these are the two rules which we are going to follow throughout wherever we needed to multiply two integers. So first rule says that the product of two integers of same sign is always positive. What does it mean? That if we have two integers and it is having same sign, we shall understand it with the help of example also. So this rule comprises two cases in it, that the same sign can be that the two numbers both are positive and the two numbers both are negative, but the result is always positive whenever these are of same sign. What does it mean? Let's understand this with the help of an example. So for example, if someone asks that multiply 5 into 4, let's take a very small example just to clear the concept. So here you see that it is a positive number, it is a positive number again. So how do we multiply this? What will come in the result? So the multiplication will be done for the numbers as we do. So 5 4s are 20 here, but this is positive, so the resultant will be positive only. The next case here is with negative. What happens when both numbers are negative and then they are multiplied with each other? So what happens is, suppose for example, if we take -2 with -4. So as you see here, both numbers are negative. So the result still comes in positive only, and then we simply do the multiplication, which is 4 2s are 8. So this is the first rule, which says if we have only positive number or only negative number, the result is always going to be positive only. Now moving on to the second rule. The second rule says the product of one positive integer and one negative integer is always negative. That is, if we are multiplying two numbers out of which one is positive, other is negative, the resultant is always going to be negative only. Let's have an example for this too. So for this, we can take the same numbers with different symbols. So we have this positive number and we are going to multiply this with negative number this time. So you can see these are of opposite signs. So the answer is going to be 5 4s are 20 and the sign will be negative. Why? Because one is positive but the other one is negative. Similarly, you can bring this number in first place and this to the second slot, but it won't matter. So here we can consider another example, suppose -7 into 3. So here comes negative number first and the positive number at the back, but doesn't matter, the answer or the resultant is going to be still the same. So here minus comes as one is negative and other is positive, and 7 3s are 21. I hope this is clear to you that how multiplication is being done. So no matter how big numbers come to you, you will be able to multiply as you know the rules. Now here comes the super important concept for this chapter, the properties of multiplication. First is closure property. What does this property says? So this property says that suppose if you have a bag, okay, if this is a bag or box or whatever is it, here we are going to collect something, and if we are saying that we are going to collect all the integers in this bag, okay, all the integers, that is the positive numbers, that is the negative numbers, and the zero itself. So that is all of the integers are kept in this bag. So no matter which number you keep from this bag, you get the integer only, right? So what does closure property says with respect to multiplication of integers? It says that if you pick randomly any two numbers, and if you make this operation, apply this operation over those two numbers, and if you again get a number which still belongs to this integer or which again is an integer itself, then it is said that it is going to follow this closure property or satisfy this closure property. Okay. So let's take an example to understand this properly. So for example, suppose we know that 5 is an integer and it's a positive integer. Okay. And if we take another number, suppose 6, it is also an integer, and if we multiply them, we have two integers out here, but both our integers have been taken from the set of integers only. Now if we multiply, we get 30. Isn't this 30 an integer? Yes, it is also an integer, that is, it belongs to the set of integers only. So this is again an integer. So this property says that no matter what number you put from the set of integer, if you multiply them, you again get an integer only, and hence the set of integer is closed with respect to multiplication. Okay, so it is said that multiplication of two integers is always an integer. This is what you understand from this property. Let's move to the second property. The second property is very easy property, which is commutative property. It's better if you remember this property by ordering, okay, by the word order in your head. So why I have said this? Because it says that the property says that A into B is equal to B into A, where A and B both are integers only, right? We write it as AB belongs to, this is a symbol of belongs to, and I is a symbol of integers. So A and B both belongs to the set of integers. So this property says that A into B is equal to B into A. What does it mean? It means that if you take any two numbers, suppose 6 into 7, if you multiply them, so no matter if you keep 6 at the first slot or 7 at the first slot, the resultant is going to be same. 6 into 7 is same as 7 into 6. This is what this property says. That is, by changing the order of the numbers, the multiplication of the resultant is not going to change. Okay, the resultant is going to be same. 6 7s are 42, and hence 7 6 are 42 also. So we say that commutative property also holds in case of integers with respect to multiplication. So now we shall move over our third property. So our third property is associative property. Associative property. So this property is given as A into B within bracket B into C is equal to, it is given as this, A into B into C is equal to A into B into C. So I will tell you that remember this in your brain somewhere just by brackets, that if we exchange the brackets, if we shift the brackets, doesn't matter. If we shift the brackets, it really doesn't influence the working here. The resultant is going to be same. Okay, no matter if we apply this bracket over here or first we apply this bracket over here and then we solve it with C. Okay, so let's understand this again. So to understand the associative property, you need three numbers, at least three numbers. So let's take, suppose if we have 5, if we have -3 and if we have 4. Okay, so these are the three integers we have taken. Okay, so let's understand this property. We take it as LHS and we take it as RHS. Okay, so LHS will be 5 into, within bracket, -3 into 4. Okay, so we are going to solve it. We already know that we are going to solve the bracket first. So 5 will be kept as it is and this will turn out as 4 3s are 12. So this would be -12. And now here, you know, we have studied right now that how the integers are multiplied. So this is a negative integer, this is a positive integer. So the answer will be in negative and 12 5s are 60. So LHS is giving us as -60. Let's see what RHS is going to give us with the same set of numbers. With the same set of numbers but with different set of arrangement of brackets. Okay, so we are going to take RHS here and here it is 5 into -3 in the bracket and outside the bracket we are going to keep C. Okay, we have suppose this as A, this is B, this is C. Very obvious. Okay, so let's solve. Again the bracket will be solved first and here it is positive, it is negative, so the answer will be in negative only. So 5 3s are 15 into 4. Again this is negative, this is positive, so 15 4s are 60 and the answer will be in negative. So what you see here is LHS and RHS are same. These are not different but just same. So what we have done, we have just shifted this bracket first over here and in the next set over here. So we have studied that in integers associative property, but with respect to multiplication we are talking about, it holds. Okay, it doesn't matter if we multiply in this set of brackets or in this set of brackets. Next we have the distributive property, which in short we say distributivity also. Distributive property. What does this property says? This property is basically A into B plus C is equal to A into B plus A into C. So what you see here, there is multiplication outside the bracket and there is a bracket and inside the bracket two numbers, two integers are being added. So what is being done? First we have this arrangement and second we have this arrangement. So what we are saying that according to distributive property in integers this property holds. This says that multiplication is distributive over addition. Why? Because this multiplication is outside and this addition is inside. So what we are actually doing is, doesn't matter if we add the integers which are kept in the bracket inside and then we multiply with this exterior number, or we first distribute this number over this first number here and then with the second number and then being added. And on satisfying this property we say that multiplication is distributive over addition. Try it yourself. Here take it as LHS, take it as RHS and take again three set of numbers. Okay, you have to take three different numbers and you have to put those numbers in LHS and then you have to put those numbers in RHS and let's see that whether both gives the same result or not. They would give, because this property holds in integers, which is multiplication is distributive over addition. There are two more properties left here, but we shall study those two properties in the next video and there only we will solve some sort of questions also, so that your confusions will be removed there.